Hello and welcome to Unprofessional Engineering. My name is James.
You got Luke.
Luke, cool experiments to do at home.
Yeah, so this one, when you said this one, number one, I was surprised you could come up with such a good idea. That was my first initial reaction.
Don't say this.
The second thing was, I can't believe we didn't do this before.
I know. Also,
this was so good.
We could do like 5 more of these.
We might, there might be a few
experiments. Let's see how people react. So I know you're surprised that I could come up with something so good, but this was actually a topic suggested by my brother-in-law, Adam, while we were sitting at a Pirates game. They were getting shut out like normal, so there wasn't a lot to do. Though, unlike normal, they actually came back to win. So that was a thing. Yeah. So thanks a lot, Adam.
We're going to dedicate this one to the Pittsburgh Pirates.
We actually might. Well, never mind. I'm not going to be mean. Luke, tell me about your first experiment to do at home.
So I'm going out strong. I'm going with the Volcano.
I love the Volcano. So, I've never done this. Have you done this before?
I've done this a couple times, actually. So I did it as a kid and as a father.
I was going to say.
So first of all, a little backstory. So what is a volcano? Geologically, a volcano is an opening in the Earth's crust in which lava, volcanic ash, and gas escapes.
Volcano eruptions. On volcanoes?
We did. So this is kind of like an homage to that episode.
Yeah.
Volcanic eruptions are partly driven by pressure, the gas, tectonic plates moving, like all kinds of things happen. And basically, it's this amazing display of nature, potentially killing hundreds of thousands of people if you're in Pompeii by chance.
Hundreds of thousands?
I don't know. Pompeii was like 100 years ago. I don't know.
A long time ago.
I have no idea when Pompeii
You're old, but not that old. Okay.
Regardless, it's a pretty amazing thing to see. Like, remember like when all the volcanoes were going off in Hawaii, and then like that one in Iceland was going off and causing all the air traffic problems a few years ago.
I do remember
Pretty
that.
Cool thing. This is not that type of volcano, but it kind of is pretty spectacular. This is a baking soda and vinegar volcano. So the reaction that you're actually getting is actually two separate reactions. The first reaction is an acid-base reaction because one is an acid and one is a base. The vinegar is the acid, the base is the baking soda. And what happens when they first mix together is the hydrogen ions react with the vinegar and the sodium bicarbonate and the baking soda, and the result of that action creates 2 new chemicals, carbonic acid and sodium acetate. The second reaction is actually a decomposition reaction, and that is where the carbonic acid formed as a result of the first reaction immediately begins to decompose into the water and carbon dioxide gas. So that's the sciencey behind it. So what do you need to make one? You need a plastic bottle, a large piece of construction paper or a couple pieces of paper, 3 to 4 tablespoons of water, 3 to 4 tablespoons of baking soda, 1 tablespoon of dish soap, 6 to 8 drops of the food coloring of your choice, and 1 cup of vinegar. Once you have all of these assembled, make sure you go on into your living room, kids, where your parents' brand new rug is. No, don't do that. Make sure you ask your parents ahead of time for any of these experiments. Make sure you go to some place where if it makes a mess, it's okay. So what you're going to do is you're going to take the water, the baking soda, the dish soap, and the food coloring, and put it in the plastic bottle and mix it all together. It's going to be like a thick kind of paste because of the baking soda and the soap and the water. Then you're going to create a cone with a construction paper, tape it, and cut just enough off the top of the cone so that the bottle sticks through that cone. Then what you're going to do is find a nice flat surface, put the bottle down, put the cone on top of the bottle, and then what you're going to do is put on some goggles, because this stuff can spatter and splits and you don't want to get vinegar in your eye. It's a volcano and it could definitely burn your house down. Then what you're going to do is you're going to slowly pour, but not too slowly, that cup of vinegar into the bottle. If you do it too slow, the bubbles come out and it kind of doesn't go in anymore. So you kind of want to do it's like a medium fast pour.
Medium fast.
And what happens is a lot of people do this without the dish soap, and you just kind of get this kind of uneventful eruption. When you do the dish soap, it gets foamy And it's amazing. And you can do different food colorings in it, and you can load it back up again and pour it in again and just make this amazing. You can also do this as like a project for school, and you could build like a display with a volcano like I did back in the day. But yeah, tons and tons of fun. This is one of those ones, doesn't cost a lot of money. It can make a mess, so be careful when you do it.
I love it. I can just envision like young Luke as a child doing this for his science fair and everyone being like, that was really great, Luke, but why was your lava purple? And you'll be like, it was?
You put food, you know me in my eyes.
I know. That's
colorblind, never hurt anybody. What's yours?
My first one, and this one's really awesome in my opinion, is instant ice. So all you need for this is a plastic bottle or a few plastic bottles, depending on how many times you want to do this experiment, water, and optionally an ice cube. That's all you need. So the instant ice experiment, really cool, really fascinating, and really interesting piece of science. So you fill up a couple water bottles with water, place them on their side inside of the freezer, and you let them cool for just a little bit over 2 hours.
Okay.
At like the 2 hour-ish mark, you take one of them out, and the water should be really cold, but it shouldn't be frozen solid inside of the water bottle, right? So after taking the bottle out of the freezer to make this instant ice happen, all you have to do is take the water bottle and smack it off of something, off of a countertop or off of the floor or whatever the case may be.
Okay.
And the water should then completely freeze inside of the bottle instantly after impact.
Freeze solid.
Freeze solid.
Get out of town.
Get out of town. It is so amazing. You need to try this.
Have you done it before? I've never seen this. I can't believe I didn't come across this one.
Oh, this is really interesting. So for better visuals of the reaction, you could turn a bowl upside down as well and like put it over a towel over it and put a ice cube on top. So here's your optional ice cube, right? And instead of smacking it off of the ground or a counter or something, you open it up and you slowly pour the water over top of the ice cube, and you'll start to see a column of ice form as it's poured over the cube. It's just so cool to see, and it's really hard to believe. But the trick to the experiment is something called super cooled water. So you're catching the water when it's cold enough to freeze, but it hasn't quite gotten to that frozen state yet. And when ice freezes, the water forms these like small crystals that gradually spread across, right? So smashing the still closed bottle of super cold water on this whatever surface you're smacking it on triggers the effect for the crystals to start forming, and they start instantly hardening.
It's a chain reaction, right?
And it's a chain reaction. And this is something they called a snap freeze. So a snap freeze is this term to describe the process when something is lowered, like water is lowered below 70 degrees C, very quickly. So this is often accomplished by submerging something in liquid nitrogen. So gotcha. Similar process here, but by smashing this off of there. So if you catch the cold water before the crystals have time to form and you pour it over the ice cube's doing that same thing as smacking it off of something hard. Like that kind of triggers the crystal formation because they're hitting something already frozen. And that's why the column of ice forms.
Interesting.
It's fascinating.
I am definitely trying that one.
You should. What do you have next?
My next one is the potato clock. And you can actually buy kits of this, which I think is cheating. So don't do this, kids or parents. So the potato clock. Parents. Yeah, exactly. So potato clock is actually powered by the acid within the potato. So you could use it with a lemon or an orange or anything acidic. But basically what it's doing is it's reacting with a positive and negative electrode. And when the reaction occurs, the electrons flow between the positive and negative, and the potato itself actually becomes the anode. So it actually transmits the power through the potato. And it does this by using two different metals. So it uses zinc or a galvanized nail. Most nails are galvanized with zinc. You could also use, and then the other one is a piece of copper wire, or you could use a penny that you would insert into the spud. So here's what you need essentially. You need two potatoes, one potato, two potato. You need two short pieces of heavy copper wire or two pennies, either one. 2 galvanized nails, make sure they're galvanized. And then you need some alligator clips. And you could do this with just wire. You don't need alligator clips. It just makes it a little bit easier and repeatable. And then you need an old LED clock that uses a 1 or 2 volt battery or a standard 1.5 volt battery. So the little square battery. So if you can get that. So basically, this is where you get to have the fun, kids. You get to disassemble the clock, and there should be 2 wires that go into the little LED display on the clock. And those are the 2 wires. Make sure you pay attention to positive and negative. So here's how you make it. You're going to remove the battery from the clock, completely disassemble it, pay attention to the positive and negative side of where that connects. You're going to number the potatoes with number 1 potato and number 2 potato. You're going to insert a galvanized nail into each potato. You're then going to insert a copper wire into each potato, positioning them as far away from possible as you can. So the copper wire and the nail should be on either ends of each potato. You're then going to connect an alligator clip between the copper wire of 1 potato to the plus side terminal of the other potato. Then you're going to connect the alligator clip and touch the other part. Once these are connected, you're then going to take those last alligator clips and connect it to your LED clock, positive and negative. Make sure and if it doesn't work, just check your positives and negatives. Essentially, you're creating a circuit with a potato in the center. So instead of having batteries there, you're using 2 potatoes. So just think of what the circuit. Cool. So just think what the circuit would look like with batteries there. You just want the potatoes to essentially become the batteries. And if you've done it correctly and you don't flip flop and have the nails go to nails, it has to go nail to copper, copper to nail, nail to copper. And then if you do that correctly, you should have a functioning clock. You can't change the clock, unfortunately, because there's no controls on it. You might be able to mess around on the backside of it.
You need some more potatoes to power that functionality.
But this is a pretty cool one. You can do this with a potato. You can do it with acidic fruit. So you could do it with a lemon. I've seen it before. But potatoes and lemons tend to work the best.
Wow, that's fascinating. I have not done that, but it feels like if anyone who listened to our battery episode, you should understand the mechanics behind all of that, right? Yeah. All right. So before we move on to my next experiment, I think it's time for us to take a break for a word from our sponsor.
Idaho Potatoes.
Not Idaho Potatoes, but something better, Luke. The Big Compute Podcast.
What can computational science tell us about the tsunami generated by the biggest earthquake to ever hit Europe? Before you know it, everything is shaking, and shaking loudly. What makes the coronavirus so contagious?
It's the machine that literally will latch on to your human cell and ultimately infect you.
And what was it like when a massive act of cyber warfare stopped an entire country in its tracks? Their ATM greets you with red text over a black screen. This is really starting to creep you out. These are just some of the questions being answered every day through the power of computing. And on season 2 of the Big Compute Podcast, we transport you to the heart of these stories, giving you a first-hand look at how computational science is changing our world. Find the Big Compute Podcast wherever you get your audio, or visit bigcompute.org.
All right. In addition to our sponsor, I do have a couple of shout-outs that I want to get to.
Who do we got?
The first one, Martin and Christopher H.
Whoa. A double write-in? What is that?
A double write-in. This is our first father-son dual write-in shout-out. So they both emailed very close in time together. Martin, it turns out, is a marine engineer who wanted to let us know that we mentioned a whole lot of garbage marine engineering schools in the U.S.
Sorry.
He went to one in Norway, which is very good. So good for him. Spent a lot of time there with his PhD. His son, so they were on a trip around Norway, right? Looking at all the beautiful scenery. He sent some pictures. It's mind-blowing. It's unreal. But his son was like meh to all of these podcasts that he had, including Neil deGrasse Tyson and his Good for Nothing Star Talk podcast. So take that, Neil. And he said, Unprofessional engineering, yes, that's for me. So above all of the podcasts, he picked us. So really appreciate that. Also, they're board gamers, so they're okay in my book. So thank you for writing in, Martin and Christopher, and thank you for listening.
Thanks, guys.
Number 2, Marty S. So Marty is an engineer that found his way into marketing, just like us.
There we
very
go.
Cool there. He understands that we're getting filthy rich and famous from the podcast, which is good for everyone out there to know. So when it takes me a long time to write back to you, know it's because I'm like counting my money and ignoring you. He suggested a future show on music media, like vinyl and 8 tracks and stuff like that, all the way up to modern day technology that I know today.
You kids and your CDs.
That's right. Your CDs, your compact discs on your home stereo. You were alive back then, Luke. I know all of that. But funny story, he realized that when I was responding to him, it was like midnight my time. And he was like, you need to go to bed. You're old enough to not be answering emails at midnight. So thanks for the concern, Marty. If any of you would like a shout out, if you'd like some of our really amazing stickers, if you want to suggest topics for us to cover, if you just want to tell us how amazing these experiments are, email us at unprofessionalengineering@gmail.com.
And don't forget to subscribe, like, share, and as always, give us the reviews. And you can always tell your smart devices to play the Unprofessional Engineering Podcast.
That's right. So I'm moving on to one that I think everybody knows exists, but maybe they don't understand it or know how to do it. Let's see. Egg in a bottle.
You say everybody. I don't think I've ever heard of this one.
Okay, so what do you need, Luke? You need some eggs. You need them to be hard boiled. You need a bottle. You need the mouth of the bottle to be smaller, slightly smaller than the egg. Maybe you should have some oil just to help make this a less dirty process.
Okay.
And then you just need like a piece of paper towel, whatever, and something to light it on fire with. So don't do it yourself, kids. Do it with your parents at home.
Well, this thing gets lit on fire at some point?
Any good experiments had fire, right? So here's what you do. You take that bottle, right? You take a little bit of that oil, you rub it on the mouth of the bottle to make sure that it's nice and slick. You take a few hard-boiled eggs and you peel them. I hate hard-boiled eggs, but this is a good use for them.
Oh my goodness, I love them.
You do. I know. So you can't just go get like a fresh egg out of the chicken. You have to like hard boil it first and peel it. So then you have that in one hand, right? Your egg. You take a small piece of paper or paper towel, light it on fire. I don't know, use your stove or use a lighter or candle or whatever. And you toss it in the plastic bottle and you set the egg on top of the bottle. And that's it. You just wait for the magic.
No.
So as it goes, you'll start seeing the egg appear to be sucked into the bottle and then drop to the bottom of the bottle. It's so cool, Luke.
I am trying that this afternoon.
I'm giving you so many good things to do instead of work. So that's really all there is to it. And so you put the oil on there. It's not necessary, but it's going to help from getting the egg from like splintering.
So why is this happening? You have to tell me why this is happening.
This is because of something called the ideal gas law, PV equals nRT. So any mechanical engineers and probably any engineer out there knows PV equals nRT. Pressure times volume equals the number of moles times gas constant times temperature.
That's my that's my back tattoo.
Is that your back tattoo?
Yeah.
Like well, I won't mention what I call them, but yes.
My lower back tattoo. That's what I got.
Your lower back stamp.
PVRT, whatever you just said.
PV equals nRT. Yes. Cool way of remembering that temperature goes up, pressure goes up. So to fix environment. So basically what you're doing is not sucking the egg in, but you're actually changing pressure. So because of the oxygen and whatnot being eaten up inside of the bottle, because of the fire, the pressure is changing inside of the bottle, and that sucks the egg in and poop, shoots it in. Now getting
the pressure is
out,
reducing inside of the bottle.
And so it's being forced down into the bottle. And so to keep it from smashing up, you put that oil on there. It helps it slip on in. And now you have an egg.
Then how do I get the egg out? You were going to say how to get the egg out.
Yeah, to get the egg out, you probably take like a stick and poke at the egg until it's broken into pieces, and then you can dump it out of your bottle.
I gotcha. All right.
There are supposed to be ways you can try. Nothing looked real successful.
All righty. My next one. This is a newspaper versus a yardstick breaking. So I remember this one, like my kindergarten teacher showed it to me, and I never saw it anywhere else. And I did a little research, and it's actually a thing. So
I don't know
essentially, so essentially what you're doing is you are demonstrating atmospheric pressure is what you're doing. So what you do is you take a newspaper and keep the newspaper folded. And what you're going to do is you're going to leave it all folded, and you're going to put a yardstick. So you need a handful of yardsticks. They're pretty cheap at usually like a craft
Busy
store.
Beaver.
Yeah. So you're gonna need a couple of yardsticks to do this. And what you do is you put the yardstick, about half of it or 3/4 of it is on a table, and 1/4 of it or a half is sticking off of the table. You're then going to take the folded newspaper and set it on top of the yardstick. And you're going to ask your friends, what's going to happen whenever I smash the end of this yardstick? Well, what happens is usually when the paper is folded, the newspaper flips up in the air and flies across the room. And then the next thing you do is you take the newspaper and you unfold the newspaper. So now you go from a surface area of about, 15 square inches to you go to a surface area of a couple hundred square inches. So you totally unfold the sheet of paper, whatever a newspaper is, and you put 2 layers of newspaper covering 3/4 of the yardstick, and 1/4 is sticking off of the table. And everybody thinks, oh, the newspaper is going to tear. Obviously, and what happens, it actually doesn't. What happens is, exactly, this is how you make money, kids, with your friends. You start taking bets and parlays on whether the wood's going to break or the paper's going to tear, because everybody knows that you should be gambling in elementary school. So you're going to ask them what's going to happen. And what's happening in this case is, because you have more surface area on that newspaper, when you go to hit the yardstick, 2 things are going to happen. One is the yardstick's either going to break and splinter automatically, like you said, because there's all this atmospheric pressure on top of that newspaper, or it'll tilt up and go right back down. And the reason being is, essentially, there is, for every square inch of that newspaper, there is 14.7 pounds of atmospheric pressure sitting on it. So when you go to a big sheet of newspaper versus a folded newspaper, you can kind of see the difference. So
that makes sense.
Yeah. So all you need is a few yardsticks and a newspaper.
Very cool. So I'm going to do one more before we take our next break. And this one is making rock candy. And I didn't know you could even do this at home.
I did this. I used to
love getting these suckers.
As a kid.
Oh, yeah. So what you need is like 2 or 3 cups of sugar, a cup of water, some skewers, or a string, something of that sort, a jar or a glass, a large saucepan, and maybe a clothespin as well to help out. And then you could also add, kind of like Luke said, pick your favorite food coloring, and maybe some candy flavoring if you don't want it to just be sugar flavored. So here's what you do. You combine equal parts of sugar and water in a saucepan and heat them up until all of the sugar is dissolved. Then you slowly add more sugar and mix it, slowly adding more sugar and mixing until the sugar is no longer dissolved in the water, like it's no longer dissolving anymore. The water should look a little bit cloudy to you as you're doing this process. And you know that there's no more sugar dissolving. Like when that's happening, this is the perfect sugar saturation that has been reached for this experiment, right? So basically what you're doing here, you're creating a saturated sugar solution. And so the temperature, like the particle temperatures can no longer, the temperature can no longer dissolve the particles.
Gotcha.
So the amount of sugar versus water should be roughly 3-to-1 at the end of this process. So originally it was even. You probably like 1 cup, then you add 2 cups in slowly until it can no longer dissolve. Of course, you can change this ratio to create more of this experiment. Add your candy flavoring if you want. You can add your food coloring if you want. You remove the sugar water from the heat and you allow it to cool a bit. You cut your skewers into the size you want, or your strings into the size that you want. And then you dip them. This is important. You dip the stick or the string in water and you roll it in sugar. Then you set the sugar coated sticks or strings to the side and allow them to dry out. Once the sugar water is cool enough to pour into the jars, safety first, using 1 jar of like whatever color you want of rock candy that you wish to make. So if you want it to be purple, use purple dye. If you want it to be green, what color dye do you use, Luke?
Red.
That is not accurate. That is true. They do. Once the sticks are dry, you carefully place them in the jar. So a stick or a string. And you want to make sure that the sugar coated sticks are completely dry before placing them in the jars. The rock candy needs the sugar on the stick to grow, and the sugar if it isn't dry, it's going to dissolve in the water that you put it into. So this is super important part of it, and make sure that it doesn't touch the bottom or the sides of the jar. So a week later, you're going to have rock candy. This is cool though, because if you're patient, you can keep an eye on it. And after one day, you're going to see just tiny little crystals forming. And each day you're going to have more and more crystals forming on this stick or the string, whatever you put in there to form your rock candy. It's really amazing. So like these tiny seed crystals that are on that dried out stick that you produced are what's going to be that starting point for the larger crystals to form. And so more and more large crystals start to grow off of those ones. So two different methods, the science part of this, two different methods contribute to the growth of these crystals on the stick. So you've created a super saturated solution, as we mentioned, by first heating up a saturated sugar solution and then allowing it to cool. The super saturated solution is actually very unstable. It contains more solute, so sugar in this case, and that then can stay in a liquid form because of the way you've like boiled it in there, right? So the sugar is going to come out of the solution, forming what's called a precipitate, known as precipitation. So this is what's going to happen to form these crystals. The other is evaporation. So as time passes, the water will evaporate slowly from the solution. And that means that sugar has nowhere to go, right?
Has to go somewhere.
It has to go somewhere. And that's when it starts collecting on that stick. And the rock candy crystals continue to grow molecule by molecule. And then you'll even see them go from tiny crystals to larger crystals big as they form. They get real big. Yeah. Your finished rock candy is going to be made up of about literally a quadrillion molecules attached to the string, like literally that number, not made up cool. James number. Yeah, it's so cool and it's delicious.
I made one of these like back in like kindergarten, middle school, grade school, something like that, and it was actually pretty cool. Fun fact: you can do it with salt. The exact same thing with salt.
That sounds not tasty as well. At all.
Not at all.
No.
You could trick somebody with it.
Oh, nice. Okay, before we continue on with the last of our experiments, Luke, I think it's time for your rant.
Yeah, so my rant is actually one of my experiments. So we'll just kind of roll right in from my rant to this. So I'm so glad this is over. But
the episode?
No, this period in my daughter's life. So if you're a parent, and you've experienced what I've experienced, you'll definitely understand this. But this is the rise of slime, I'm going to call it. And I remember when it first happened, I was like, oh, okay. We'll make some slime. It'll be fun. It'll be like a father-daughter family kind of thing. We'll do like a little thing in the kitchen, and it'll be we'll pull her little stool up, and she can stand on it and work at the thing, and and it was great. And then it turned into, I would say, an unhealthy obsession for my daughter.
I think that happens with kids. Yeah,
and it became like it was a problem in our family. Like the lack of having any baking soda in the house, or shampoo, or dish soap, or laundry soap. Like literally, like Tupperware was disappearing. She was going onto Amazon and buying boxes of borax.
Oh yeah,
because we have and it's just so. Number one, they had to think we were like building a bomb or something. Like, who orders 14 pounds of borax other than like a 9-year-old girl making 85 pounds of slime?
Oh my gosh.
I mean, it was the most unhealthy obsession ever. And YouTube, I'm going to blame as well, because there's all kinds of kids that they had channels devoted to making slime and the best way to do it. So that's my rant. I'm going to roll right into slime because...
Can I apologize to my brother-in-law and sister-in-law for all of the slime that we've provided your children? I'm sorry.
Oh, you've done this as an uncle. Made slime with them and sent it home?
Made slime with them at their house, sent kits to them to make more slime. Oh, absolutely, then leave.
Okay, so slime. So if you don't know what slime is, Good for you. You're in a good spot. So slime is a non-Newtonian fluid. And basically all that means is it's a fluid that does not follow Newton's laws of viscosity. And Newton has these laws of viscosity. And basically viscosity is, for making it in simple terms, it's how like thin a liquid is. Like oil has a certain viscosity, water has a certain viscosity, syrup has a certain viscosity, cold syrup has a different viscosity. So a non-Newtonian fluid, viscosity changes when it's either under force, or in some cases it has a temperature reaction as well. So if you think of syrup as my example, so syrup, whenever it's nice and warm, the way it's supposed to be poured on pancakes, it's nice and thin. But if you're like my mom and you put syrup in a refrigerator, which is the worst thing to do, and you pour syrup, it's really thick. So so that's a non-Newtonian liquid.
Keeps it in the fridge?
Yeah. Like water is not a non-Newtonian fluid. Water, whether it's cold water or hot water, the viscosity is essentially exactly the same. A cool one that I've seen is they do with cornstarch. If you throw a ton of cornstarch in water, if you push your hand in it slowly, your hand just submerges. If you take your hand and you smack the cornstarch water, it actually bounces off and doesn't go in. So that's essentially what slime is. It's a non-Newtonian fluid. And what you need to make slime is you need, this is one batch. You need 3/4 cup of Elmer's white glue. Has to be Elmer's. I don't know why. Nothing else works. The cheap stuff doesn't, parents. Sorry. You need half a tablespoon of baking soda. You need 1 cup of water. You need 2 to 3 cups of shaving cream. And this can't be the gel. It has to be like Barbasol, like old school shaving cream. I love the smell
of Barbasol.
It is good stuff.
Yeah.
You need 1.5 tablespoons of contact lens solution. There's a few chemicals in there that make this happen. You need food coloring of your choice. My second experiment with food coloring. And you need about 15,000 Tupperware containers. So once you have all this, you're basically, it's an easy one. You just mix everything together. You're going to play with it for about 5 minutes, and then you're going to make about 30 more batches for absolutely no reason. Then for the next 2 to 3 months, you're going to find Tupperware containers underneath your daughter's bed, in the bathroom, like in random places, under the couch, everywhere, all over your house. So parents, if you can avoid this slime craze with your kids, and I doubt you can, it's a force that can't be reckoned with. Avoid it. Because it was about a 3-year thing with us, and it became, it was a problem. We pretty much had to send her away to a special slime camp where she had to like get off of slime. So
that's rough. Yeah. I've heard nothing good. I was not allowed to have slime when I was a child, and I was only allowed to play with Play-Doh in our basement on the cement floor.
I never knew slime was a thing until my daughter started making it, you know.
Yeah.
What's
all right.
Your
last experiment for me, capillary action. So the capillary action science experiment also can be known as the walking water experiment, which is kind of neat. So mom and dad, just so you know what we're talking about, so that you sound like you know what you're talking about to the kids. Capillary action is the process in which a liquid moves up something solid, like a tube, or into a material with lots of small holes in it. This happens when 3 forces called cohesion, adhesion, and surface tension all partner up and work together. So water, pow is
that's right, what it sounds like when capillary action happens.
That's not accurate, but yes, water molecules are considered cohesive. They stick to each other, and they adhere or stick to a paper towel. As one water molecule moves up this paper towel, it pulls the other molecules along for the ride, right?
Because they're sticky.
They're sticky, and the lazy ones get pulled along. So that's good. The molecules pull each other along, just like a string getting pulled, right? So capillary action science experiment, super simple. You need just a few materials: paper towel, water, food coloring, so that you can see the magic happen.
That would be cool.
That's in glasses.
Like with red, so it look like blood.
I mean, I wouldn't say that. I'd go with green and blue and friendly colors, but okay, Luke. Start putting 7 glasses on the counter. Fill up 1, 3, 5, and 7, the odd numbered glasses.
Okay.
Most of the way up with water. Next, add food coloring to the glasses, like 5 to 10 drops of red to make it like blood to glass 1 and 7, 15 of yellow food coloring to glass 3, and 5 to 10 drops of food coloring in glass 5 of another color. Finally, take your paper towel and fold it in half widthwise. Fold it again and again and again. So that's fold, 4 folds, Luke. Now put one side of the folded paper towel into one glass and one into the another glass. So basically put it into the open one and the closed, or open one, the full one and the empty one, right? And repeat this with the remaining cups. So then you just watch the capillary action in motion. So as the water starts to climb up, like you kind of have a folded V shape, it climbs up one side and then it starts going down the other side. But what's really interesting is that since you have them all going and touching each other, those colors begin to start to merge as they combine. So not only do you have your, let's say, red, yellow, blue, but they start to make the colors of the rainbow because they climb and start coming together. Yeah. And so the ones on the bottom will connect together. And so they'll start working their way up, climbing up the other one as the color coming down starts to pull them up. So you just get this beautiful rainbow looking paper towel display that you have created.
That's super
cool. Really simple to do, but really kind of neat to watch.
I like that one. I'm gonna have to try that one.
Yeah.
So I have 3 experiments that you should not try. And
let's end on that.
Personal experience.
Should have let off with this one maybe. But
yeah. So the first one is the Mentos and Diet Coke thing.
Ooh,
it never goes well. That bottle hits someone in the eye, the cap pops off. If you do it in the house, you end up with Diet Coke everywhere. There was a reported, and I don't know how busy it is now, and I don't know exactly when the number was, but there was somewhere in the neighborhood of like nationally, like 9,000 Mento Diet Coke related, not deaths, because no one like died. I mean, maybe someone died, but there was like 9,000 injuries. I was reading somewhere, and again, I don't know the validity of that number, but I'm sure people getting hit in the head with the bottles, the caps, all that sort of stuff. So don't do the Mentos and Diet Coke. The next one is homemade candles. I did try the Mentos and Diet Coke one and made a huge mess. The next one is homemade candles. And the idea of homemade candles sounds great. You get some beeswax, you get some mineral oil, you get a couple of other things, you get some string. What could go wrong other than spilling the beeswax and everything all over your stove? And if you ever tried cleaning up boiling beeswax in mineral oil and other candle making waxes,
you could use capillary action to start.
Oh my goodness, it was terrible. And then this last one, I don't remember when I did this one. This was maybe high school. I had like this 3 or 4 day I want to save the planet kind of period in high school.
3 or 4 day.
And I saw this thing where you take plastic. So remember when I was in high school, paper was all you had. Plastic bags were like the new thing, like in high school. And it was like, and back then it was like, they're going to kill the planet and pollute the oceans. I think
it's still that way.
And it actually came true because plastic bags do kill the ocean. And what I saw was you take plastic bags and you melt them in your oven in a cookie tray. So you fold them up and like make knots out of them. And you lay them in a cookie tray, and then you basically bake the plastic at like 450 degrees, and the plastic bags melt, and then it cools, and then you flip it over, and you got this big piece of plastic, and you can cut it and like do things with it. The problem is, if you have a cheap cookie tray, if you ever heat a piece of metal and it twists, I did that. Molten plastic bags inside of my mom's oven.
Oh my goodness. That sounds terrible.
Yeah, I did it one time and I was like, you know what? I'm not saving the planet.
Yeah.
Now I keep all my plastic bags when I visit the beach.
I was going to say, I thought
you in the ocean
might throw them on the fire on top of your styrofoam and your old used batteries.
I don't do any of that, kids. I recycle.
Luke, this was so much fun. I love this episode. I think we might need to do another one or two. I think some more out there. If any of you have some awesome experiments you used to do as a kid or that you've recently done with your kids or as a kid, why don't you write into us at unprofessionalengineering@gmail.com. And until next time,
see it.